Okay, so this problem, they are just asking you two more examples of how to find what is the relative intensity, how shrill is the sound of the whale, and how you say it, John? Cicada? Cicada. Okay, so first of all, let's do only the whale part, and that's to find the relative intensity of blue whales whose sound is given as 188. So that means around this decibels. This part is the L. Can you write down in your notebook? So that's the L, right? So in the formula, there it is here. So here, L is 10 times logarithm to the base I of I. Okay. So next thing to do is the earthquake. So let's plug in it. So L represents 188. So we'll write down 188. 1 equals 10 times logarithm to the base 10. So the 10 is the real common number they call it. The common number means it's an easy number 10. So that's why they use the logarithm to the base 10 of, and the I is what we do not know, right? We don't know what is I. And you can use your common sense also and get the answer directly. Okay? So first thing is to solve for x. So how do we solve for x? So you divide first by 10. Both sides, divide by 10. See? Okay. Any questions so far? Yeah? Cesar, okay? So this 10 crosses us. This 10 and this 10 goes away. And 188 divided by 10 is 18.8, right? Do you agree with me? You can check. If you get confused, check with the calculator later on, not now. So this is logarithm to the base 10. And all you do is, the form that you see is called the logarithmic form, because there's a log there. And we need to change. So this part is in the log form, and then you need to change it to the exponential form. And the exponential form, again I repeat, if you get confused, right here. So if there is a log form, that's the base B pink color, so that's like the 10. So the pink color is like the 10, it is right here. And then the green is the number, this one. You're like, okay? So I'm just trying to make sure we get this 100%. This is 18.8. And the blue is the x. So this is that I is x, right? So how do I change it to the, and this is where I still, students are getting confused. How do I change from logarithmic to the exponential form is, you always begin with the base here. That's the main one. So you put a 10, right? 10 raised to, so this pink color, this one, I'm using the red or orange color here. So that 10 raised to the green one, 18 point. Is that okay? Makes sense? Equals, yes. Now 18.8 is quite a big number. You can always say, put on the calculator, you can see 1 million is 6 numbers, 6 zeros, correct? 1 billion is 9 zeros, agree? 1 trillion is what? 12 zeros? Then 15 zeros is what? Quadrillion, correct? Million, billion, trillion, quadrillion. Then quintillion, 18 zeros, and this is like quintillion. You can always check with the calculator. So, but what I want to do is, on the thing, you don't have to do on your thing. I'll just show quickly. Let's see, because you're supposed to use the Desmos. We'll really see what is this number, and I'll just put Desmos. You see, and I'll just put 10 raised to the power 18 point. Can you see that? So it is 6 points up. So the answer is 10 raised to 18 point is how much? 6 times 10 raised to. Remember? This is quintillion, 18. Quadrillion is 10 raised to 15, right? Trillion is 12, 10 raised to 12. Billion is 10 raised to 9. Million is 10 raised to 6, right? So that's quite a big intensity of the blue whales in the ocean. So hope that guys. And next one we do is quickly go. Let's do fast the other one also to get an idea. What about cicada? Let's see. Cicada. Cicada is says it is 106. So the second question is cicada. Sound of cicada. How do you say it? And its decibel is given as 106 points. Can you write down quickly? So beautiful it is to know why maths is being used in real life, just to understand all this sounds. So in this example, what we change is everything seems to be same. The only change here is this time you will write 106.7 times 10, right? Is it okay, Diana? So you do the same thing, divide by 10, then change it to the exponential form, and then use the calculator, and you get the answer. How many of you understood so far? Thumbs up. Wow, that's so cool. And I never expected this, and there's so many of you have come. It means you're even though we don't know rocket science, but at least, oh, okay, we don't know something about how to measure the sound in decibels using the log formula. That's all it is. Right, Jaylee? Okay, so what I'll do, I'll skip this, the rest you do yourself. Let's go to the next problem, okay? I want you to copy down this next one about earthquakes. So I'm gonna just copy down this part, not everything. Yes, Tatiana, can you read this question loud so that everybody gets it? Please don't copy the question, it takes a lot of time, okay? I don't want the main information you write in your notebook. Yes?
The magnitude of an earthquake is
Did anybody hear? Did you hear what you said? Can you say it a little loud, Tatiana?
The magnitude of an earthquake is measured on a logarithmic scale called the Richter scale. The magnitude m is given m log 10x, where x represents the amplitude of the seismic or wave positive
Seismic wave, yeah. Pauses.
ground motion.
Okay. So first of all, Richter scale in the year 1934 around is a seismologist. He tried to measure earthquakes like in different cities areas. How to? So they use the name itself is. His name is Richter, right? Actually, his actual name is Charles. 1935. I'm not sure, but that's the time he was working on kind of research how to measure different earthquakes, different cities, how big it is, right? So they try to see the ground vibrates. Whenever the earthquake, it shakes. The whole thing shakes, right? So they want to see the vibration. So this the scale they use something like this. So this scale, when the earth shakes out, so this is what it does. Sometimes it becomes higher. Can you see? Can you see what I'm doing? So it vibrates. So that the formula you see in the logarithmic formula I gave, not this. You see the earthquake R is what the amplitude of the seismic wave. So when we talk about this, these are the waves. Can you see this vibration? So the amplitude is something like how high. This is that R we are talking about. Got it? So how much? So it always it represents the amplitude, and then M represents the magnitude of the earthquake. So the formula is M. So just write down. It is 10. Base is 10. Magnitude is logarithm of the whatever the magnitude is. You just put 10, and that's it. So this kind of things are seismic wave. You can see if you throw a stone in the water, you'll see the ripples of water going, right? Wavy shape like that. So it's the same thing, ground vibration also. Wherever the earthquake or movement of the tectonic plates happens, you know how the earthquakes are formed at the ground underneath the earth. There is a movement of like the earth, two bodies moving. And that happens and it moves. It's called seismic wave. It goes around, all around. Am I making sense to you? Nobody's saying yes. Correct, right? So when the earthquake happens, the epicenter is the main place, and then it goes like that, and it affects everywhere. Of course, it affects the main area, devastates there, and little when it crosses beyond that. So whatever it is, the main thing is, oh, that's the Richter scale. That's the magnitude, and that's all you do. So what the first question is, HR, can you read this question?
How many times?
Amplitude.
How many times?
What?
How many times a great or as great is the amplitude?
I know it is not big. I can't even make it a little bigger. I don't know. It's like slideshow. Like I can't zoom in also. Anyway, caused by an earthquake with the Richter scale of 7 as an aftershock. So there are two. This is like comparing two cities here. One city has a earthquake of 7. The other city is earthquake of 4. So how much is greater is the magnitude of this one or the intensity? So the question is how many times greater? So that's what we want to know, how many times bigger. So let's use this formula. It's the same thing. The good thing is you don't have to divide 10 here. It's just straight away formula. So let's first. So let's call the city 1. I'll call this as city 1. City A, it says a 7. So the Richter scale is 7. So M is 7. And city B is M is, what is that? Nobody's saying. 4, right? So 2. So 2 cities are given and the Richter scale. So if you see on the newspaper or on the TV news, oh, there's an earthquake in Syria around 7.9, I don't know what, but around something like that, it devastates the whole city. And here it is 7, one place, another place is 4, and so you want to know how much more intense was the city A compared to the city B. Is that okay? Nobody say yes. Maths has become a little interesting only if we know whether it has some relevance in real life. See? Danitza agree? Alejandra? Today last day? Friday, right? Nobody say yes or no? Friday. Let's do this quickly. And thank you for those who are really showing interest and those who are participating. Those who participate always get good point. Remember, if you try to go beyond whatever I expect, I mean that's not fair. I give good points, but I see some people are off task, and that should not happen. Right now we are focusing on this. Your mind and heart and soul should be there, doing your work. Even if you know something, and go beyond it and write down the whole thing. Okay, city A. Let's do this part. 2 parts on the left and the right. So the city A has M is 1, so this is 1. I'll put M is 1, this is 2. So let's write So we are working on this 68, right? The one that says two cities with 7 and 4. So n1 equals, so the n1 is logarithm to the base 10 and r. So r is the relative intensity. Or on the Richter scale, it is like movement, the amplitude, how high it goes. So it means it's like this. See? So that's the maximum it can go. That's what that means. From this spot to this spot. That's the amplitude. This is the amplitude. Make sense? Of course, it goes down also, but it's always with compared to the midline. It is called. Make sense? CCP time will come very soon. Okay. So n is 7. Put a 7. Everybody put 7 quickly. Then logarithm of 10, the amplitude, and then you change this to the. So once you have a log form, you just have to change it in the log exponential. That is, would you like to tell me what will be this? In the, come on, try. How do you change? What do you start with? What is the base here? What base do you see here? So if you forget, please remember that formula right here. How do you change from the log? Liana, can you help quickly? Try. Haley, would you like to try? Marcus? You all have to, all you do is you compare this log there, over here, right? Jaden? 10. Katyana? 10 raised to 7 equals the answer. That's all it is. So I will call this as R1, that will be the first city, or RA. RA stands for the city A. The A only represents which city are you talking about? So that's like RA. And you're done. This is the first part. And the second part is city B. So I'll write M2 is logarithm of the second city. B, let's call it B here. This is city B. So this is A. So A and B. And the second one you see is given to you, decimal is 4. So 4 times logarithm of RB to the base. Any question, headline? And then you change the same thing. The base is 10. So this 10 raised to 4 is the intensity of the earthquake in the city B. Then the next question you just want to compare. Once you have this, you want to compare R. You have to take the ratio of the amplitude of the seismic wave, or on the Richter scale, the wave, the ratio of the intensity of the, or it's just the amplitude of the seismic wave. What is the maximum? RA, here we got it as 10 raised to 7. So 10 raised to 7 divided by the other one is here it is. That's the amplitude. That is 10 raised to 4. And then you just, the bases are the same, using the laws of exponential, you subtract. and you get 10 raised to 3, which is 1000. So what it means is the first city is 1000 times the second city. The question was asked, how many times great is the amplitude? So you're comparing the amplitude of the first city earthquake and the second earthquake, and the amplitude is the second one, the first city was really 1000 times the second one. That's what it is. Make sense? How this? No. So far so good? So not just trying to do 100,000 of problem, but see how beautiful it is to see how to compare two cities, correct? So what are we comparing? Two cities, how much is the magnitude, how big was the magnitude caused by the first city to the second city? Do you agree? I remember, did I give an example, Vivian, yesterday? Jaden, about money? Okay, just watch this. Rebello, I have $15. Everybody agrees? Jalen, you have how much? $10. Can you tell me how much more I have compared to you? How many times more I have than you? How do we do that? So I have $15, Jalen has $10. How do I compare how much time money that I have with you? What do we do in order to compare how many times bigger than? At least we know I have more money than you, at least Jalen. Rachel, can you tell me this? How do we do? I have $5 more than, correct, right? Because Rebello is making a lot of money in the school, so 10. So I have 50. JD is not working yet, so she has $10. So I have 5 more, right? That's like common sense, right? But the question is, how many times bigger is mine than 2? Times. So would you divide 15? Jamie is saying, why don't you divide 15 and 10? Is that okay? Will this be better? So why you say divide 15 by 10? Why this ratio is important? So I'm going to write on the left to build up this. So Rebello will be up, Jalen will be down, right? Correct? Do you agree? How much is 15 divided by 10? Liana. What is 15 divided by 10? Just 1.5? Correct, right? So that means Rebello, so I have 1.5 times what Jaden has. So Rebello is 1.5 times Jaden. Do you see this? Now, why I'm saying this is just a common sense, but when it comes to measuring the earthquakes in two different cities, we need to know how many times in the first city, how many times great is the amplitude. Can you see this word, amplitude? The seismic graph, the Richter scale, how high it goes. You want to know how many times it is grade is amplitude on the Richter scale of 7 and 4, and you can see that it's 1,000 times more. Is that okay? Nobody is saying yes. Agree? Did you get? So it's so beautiful to know these things. Not just we saw about those other problem about how to measure the loudness of sound. How loud I'm talking to you. Kimberly, I'm talking to you. Can you tell me what is how many decibels is my sound? Anybody remember? Tatiana? Turn your pages quickly. See that I'm talking to you. What is my sound? 60 decibels. You know what? And when these two people are talking, what is that sound? 20 decibels. So the goal is just not doing thousands problems. Get this, apply in real life. You see what's happening. Okay, so this was one. Let's do another one. Okay, can you copy this question? Quickly, let's go to how the doctors and the how do the doctors maybe pH of a blood. Okay, the regular pH is 7, but here there are some questions. I want you to quickly write these 4 problems, and we'll do one together, and I'll walk around, and you can do the other 3. So one example I will do as a group, and then we'll see. Okay, first copy the whole question. So in the exercise, as you write, I'm just going to read this. Use the information at the beginning of the lesson to find pH of each substance. So we have 3 examples of ammonia, vinegar, lemon juice, and oranges. Everybody has oranges, right? So it has, what is that means like? So in chemistry, of course, your science teachers need more showing exactly what is the meaning of these moles and all this, but as a mathematician I can say how to use this. So what is pH? That's what is pH. How do we figure out for these 4 different solutions? Okay, so let's do one together, okay? And then the next 3 you are supposed to do. If anybody has a question, how to go about, we'll see as a group. I mean, individually. The first one I'll take it straight away. You do 26 oranges. Let's talk about oranges. So every time we go for the lunch or even in the morning breakfast, the school provides us with juice, right? Really? Do you agree? Okay. Orange juice. First question is, look at the chart. I'm letting you think of what do you think the formula will help you. Can you talk to your partners and decide, hey, which formula has, what are the, I have not showed you yet nothing. Can you at least figure it out yourself? You can just talk to neighboring, whoever it is. Kind of lost, right? Nobody wants to talk to this person.
We do that sometimes.
That is anything strikes you. It's okay. Like, see, this is not. I know is really confusing because this is a real application in life type of thing, not simple easy maths. You have to. Why the hell we learn this? The main thing is why when we want to learn this. See how it is connected. There's anything striking here? Nothing to do with that chart and this problem. At least one letter come there. So my first question, do you think it's the first formula? So as we progress, everybody right. Do you think it's the first formula? Come, yes or no? Say no or yes. No? Why no? Can you talk aloud? And so your loudness of sound should be greater than that one. See, the decibel is making that projector is making sound also. It's like a mixer in the grind, you know. The mixer makes so much loud in the kitchen. This is something similar, irritating sound, right? So it cannot be the first one. Agree? Yes or no? Can this be the formula? This is about sound. We're not talking about sound here. What about the second question? What is this part? Earthquakes. Are we talking earthquake here? Is anybody shaking the whole ground? Nothing. Nothing is happening here. So what is the only option left? pH of solution. And the pH is more in science. I think even in middle school they have that. They think about, the doctor and the nurse is the first thing they check when you go to the hospital. What is your pH of your blood? Okay? So what is that pH? I can say as a mathematician, it is only like how much is there's something called hydrogen ions in the solution. Okay? So there they gave you, each one is given you some H plus. Do you see H plus? Hydrogen ions, which is in moles per liter. So every liter, how many moles are there, kind of thing. Okay, so for me, in this case, the formula is right here. Everybody copy this question. So pH is minus So pH, let's write down. So this as a group we will do, and then see there are 4 of them. One of them I will do, and the next one you have to do it yourself. I will assist you. If you get confused, that's okay. We can always work it out. So the last one is orange juice, because that's every day we have this, almost every alternate day maybe. And so orange juice is H plus is given 3.16 times 10 raised to minus 4 mole per liter. Okay? Is that okay? Kimberly? Do you like to learn this, Kimberly? Why? What could be the reason? Jalen? Is it nice to know at least something about pH? The doctors use. To tell you the truth, long back 2007, my wife was sick in the hospital, almost dying. And there was something like, they were every day checking pH, and I was thinking, what is that time? I didn't know exactly everything. But then I said, okay, pH every day, the blood test, every day. How much is the pH? They want to make sure it is acidic, less acidic. So let's put the formula. pH equals minus logarithm H plus and to the base. So there's no base means 10 raised to 10. Can you write down? So the base is 10. So the pH is equals minus logarithm to the base. What do I replace H plus by? Huh? Should be replaced by 1? What's that? This whole thing, can you see? Replace the whole thing. So let's put that. So it is 3.16 16 times 10 raised to minus. Is that okay? I'm just plugging in. Now some of you will say, well, what the hell? What is this 3.16? Actually, you know what the scientists, they have seen that they try to measure in terms of kind of, I'm just trying to show you here something maybe not perfect. So they started with something like 0.02 like this, then 0.01, 0.001, 0.0001, 0.4 zeros and 1, then 5, 2, 3, 4, 5, 1, 0.1, 2, 3, 4, 5, 6, 1. You see what I'm happening? So they wanted to know how many moles are there, and usually this last part is, this is that actually around. So they said, okay, this is 10 raised to minus 2, so they say, let's call it pH is, if it is minus 2, call it 2 here. This is 10 raised to minus 3, so let's call it is plus 3. If this is like this, let's call it 4. Because this itself is 10 raised to minus 4. This is 10 raised to minus 5. This is 10 raised to minus 6. This is 10 raised to minus 7. So they say, okay, 7, 6, 5. So these are easy numbers to figure out the pH. So this is the pH. And this is called number of hydrogen ions, that H plus. In 1 mole, this number, they are so stupid. And see how that in science, scientifically it is so confusing for us. But those who are in the research, pathologists, they do that research, right? They do the blood test, they see those microscope and everything they do. We don't understand why. Some of you will be like doing that work. So this part is, so those are like a pH we call it. So the water that we drink is 7. Make sense? So this is the water. Can you see that? So the normal water is this one. So this we write, and then finally what we do is, this part, there are two of this, 1 and 2, the formula, look at this formula. So if there is a multiplication, you separate the log. So what this means is, equals minus log of the first plus log of the second. Can you write it? We are almost finished. So I'm using this logarithmic formula. So this is the formula. Let me bring it here. Look at it. So if there is a multiplication, what I do is, it's like, this is the little hard part. This is the hard part. And some of you wonder. And then we'll continue this. This part I'm going to really show tomorrow, because you have to get this tomorrow or Monday. And I hope this helps. The question is, did you get something at least? Got it, right? Thank you.